my dear students, welcome to our channel MS2 Physics, where physics gets charged. The last video we discussed the concept of speed, average speed and different cases of average speed. So now in this today's video we will discuss the concept of velocity, average velocity and instantaneous velocity. And before to that, at first we will discuss the velocity and what is the difference between velocity and speed. Okay, so here previously we discussed the speed is nothing but the total distance traveled per unit time is said to be speed here, and its units are meter per second, or the CGS units are centimeter per second. These are the SI units here, and we can also measuring the speed in terms of kilometer per hour. And if you want to convert this kilometer per hour into meter per second, you should be multiplying it with a 5/18 so that it can be converted into meter per second. And as distance is a scalar quantity, so the speed is also a scalar quantity, right? Coming to the velocity here, the velocity of a moving body can be defined as the displacement of the body per unit time, which means we can write here velocity is equals to displacement by time here, as displacement is measuring in terms of meters and time is in terms of second, so that its units can be written as meter per second again. So centimeter per second are the CGS units here. Here the velocity is also be measuring in terms of kilometer per hour, and the conversion is same as in similar to that speed is a 5/18 meter per second is equals to 1 kilometer per hour, right? So now the major difference between the velocity and speed is, as it is displacement per unit time, as it is a distance per unit time, for a course of motion, distance is greater than displacement. Distance is greater than displacement, so that we can write that the time interval is per unit time only. So speed is definitely greater than velocity. Speed is definitely greater than the magnitude of velocity. And one thing, when the body is moving along a straight line, so that the distance and displacement both are equal. When distance and displacements are both are equal and both will be defined per unit time only, so we can also be write speed is greater than or equals to velocity. Is the first major difference between the speed and velocity. And the second point coming to here, as it is a distance per unit time, distance is a scalar quantity, so time is also a scalar quantity, so that the speed is a scalar quantity. Whereas coming to the velocity, as it is a displacement per unit time, displacement is a vector quantity, which we learnt in the previous videos only in the vectors, right? So that here the velocity is also a vector quantity. When it has a vector quantity, it has both magnitude and direction. It has both magnitude and direction, whereas it has only the magnitude. So that's why I am stating that the magnitude of speed is always greater than the magnitude of velocity. In the case when the body is moving along a straight line, whether you are stating velocity or speed are same, because of the distance and displacements are equal, so that you can write speed is greater than or equals to velocity. Or in sometimes in the examinations they may be asking the question ratio of speed to velocity. Ratio of speed to velocity is definitely greater than or equals to 1 here. And now when you are coming to the dimensional formula of this, so as we have only meter, there is no kg, m0, meter is the length, L, second is the time, t minus 1. Similarly here also when coming to dimensional formula, same only, there is no kg, so kg mass 0, meter is the length, second is the time, so m0 L t minus 1, or simply you can write a L t minus 1 is the dimensional formula for either velocity or speed here, right? So now coming to average speed, this average speed is the total distance traveled by total time taken, means sum of the time intervals. In the time intervals the corresponding distances covered by the body, the ratio of these two is gives the average speed, right? So when coming to here, the average velocity for a course of motion, the change in position of the body between two intervals of time, is gives the average velocity. Means here again this change in position, why I am writing the position vector, means here when the body changes from one point to another point, there may be a number of paths to flow this, but when the line joining the shortest one from initial to final is gives the position vector, by this displacement by time is said to be average velocity. To understand this clearly, I would like to explain the average velocity by taking the graphical representation, by plotting the graph position versus time. So here I am taking the position on y-axis and time on x-axis and plotting the graph by observing the positions of the body at different intervals of time, so that I got this kind of curve. So by this graph, if I am consider the position of the body in the first time interval t1, so definitely it gives the position x1 is the initial position time interval t1. So now in the time interval t2, again if you want to know the position of that body, moving body, so that here it is the final position of the body here, right? So when I am coming to the average speed, the total distance traveled by total time, so in such cases you are considered the path along which the body moves here. But now I am coming to define the average velocity. I am defining average velocity, okay, so that here simply the line joining from initial point to final point is gives the displacement of the body. So let this is the initial point A and a final point B at the time interval t2. So the line joining from A to B is gives the displacement. So this displacement can be obtained here. So from O to A, this is what gives the magnitude of x1, and here it is the magnitude of x2. Okay, so that, and this is the time interval t1 and this is time interval t2. So this is what the time interval t2 minus t1, and here it is the x2 minus x1, x2 minus x1. So in the position time graph, when you are taking the tangent, tan theta is gives the slope. So from basic mathematics we know slope is, from basic mathematics, slope m is equals to change in y coordinate to change in x coordinate. Change in y coordinate to change in x coordinate. Here what we took the y coordinate, in our graph we are taking the y coordinate as position, so that you can write delta x. On the x coordinate we are taking the time, so that you can write here delta t, which means the slope of a straight line in a xt graph is gives the velocity. Why? Because delta x by delta t, x by t gives what? Velocity or not? So that pointer we can write here. So as I am written, average velocity is equals to delta x by delta t, so that v average is equals to delta x we can obtain from the graph is a x2 minus x1 upon delta t is a t2 minus t1. So this is the way we can find the average velocity of the body when we have the two positions here, x1 comma x2 are the positions of the body, positions of a body in a time intervals t1 and t2 here. Which means the observable point is here, while you are defining the average velocity, just you are consider the initial point and final point between these two consecutive time intervals, but not the path along which the body moves. Means this average velocity is obtaining by considering just two positions on its path of initial and final, but does not considering the path in between them. Which means if you want to know the velocity of the body or the position of the body other than these two intervals, later this is a t3, at this point, at this interval of time, if you want to know the average velocity, it won't be gives the information about that. Which means here when I am taking this is a t3, at this point the position is this, and here the corresponding coordinate is x3. So again, to know the velocity at this point, again we need to join the line, from A to C. Again we should take x3 minus x1 by t3 minus t1. Like that means while finding the average velocity, just we are consider the initial and final positions in the time intervals, but not consider the path along which it moves, means which does not give the information about the velocity of the body other than those 2 points. Even if you are taking the time interval here, it is the position, here it is the position, that the line will become steeper and smoother, means will become small, delta t tends to 0. Delta t tends to 0 means for any small interval of time, it won't be gives the information about the velocity or position of the body at that instant. So for that we are introducing one more physical quantity. That physical quantity is said to be instantaneous velocity. instantaneous velocity, which means instantaneous velocity can be defined as it is the velocity of the body at any instant of time at particular point at particular path is called instantaneous velocity. Instantaneous velocity is a velocity at any instant of time, simply said to be velocity at any instant of time during its motion is given by the instantaneous velocity. So this V instantaneous can give for any instant of time the time however may be the small, so that it can be written as a limit of delta t tends to 0 of the average velocity. Why? Because see, when I am considering these two intervals, again between these 2 points I am considering the delta x and delta t. If I am consider the point here for these two intervals, delta x, delta t, for this delta x, delta t, whatever the time intervals is small, however maybe the interval is small, we are taking the average in that time interval is use the instantaneous velocity. And from basic mathematics, this limit of delta t tends to 0 of delta x by delta t can be written as dx by dt. Can be written as what? Dx by dt. Means here it is read as the rate of change of position with respect to time is defined as instantaneous velocity. It can be defined as the rate of change in position, the rate of change in position with respect to time is defined as instantaneous velocity here. That is what major difference between average velocity and instantaneous velocity. So while we are defining the instantaneous velocity, we are consider the path along which it travels, so that the important point is here the instantaneous speed, magnitude of instantaneous speed is equals to the magnitude of instantaneous velocity. We can say that the magnitude of instantaneous velocity is equals to magnitude of instantaneous speed. Why? Because while we are defining instantaneous velocity, we are consider the path, but whereas while defining the average velocity, we are not consider the path along which it travels, just it consider the initial and final position in between the given interval of time. Okay, so to understand this clearly, I am giving small example to understand this average and instantaneous velocity. So when I am coming to our IPL 2020 matches, you know the 2020 matches very well. If any team from 0 to 20 overs, if the team made 200 runs, the team in 20 overs, the team made 200 runs, which means what is the runs per over? They are giving the runs per over. Runs per over, how could you find the runs per over? From 0 to 20 overs, the team made 0 to 200 runs, means number of runs made by the team divided by the number of overs that played is gives the average run rate or runs per over. So this is what gives 200 by 20, 10 runs per over. Means this 10 runs per over is the average run rate of the team. Does it by means in each and over this 10 runs only made by the team? No. Otherwise, if you want to know how many runs made by that particular team in the 10th over, could it gives the information about the number of runs made by the team in the 10th over? No. In a one rain, so in a 1 over, it may be made 15 runs. In the second over, because of falling 2 wickets, that may be only made 2 runs. And then after, in the next over, the 10 runs, 6 runs, like 20 runs, 5 runs, 4 runs, like that pie chart is changed. In the last over, the team may be made 30 runs. Means the different overs, the team made different amount of runs, but on averagely in the entire 20 overs, the team made 200 runs. Then runs per over are 10. It is not by means of in each and every over that runs made 10 runs only. Of course, in some of the overs it made 10 and in some may not. And here this instantaneous in sometimes greater than this average runs per over and sometimes is less than runs per over. Understood? So for that you need this pie chart, so that only you can know the how many runs made by the team in particular over. Like that, here also while I am defining average velocity and instantaneous velocity, basically the velocity is the displacement by time, speed is the distance by time. It is not by means of in a regular interval structure. In every 1 second the body may or may not be covering the same distance. In 1 second the body may cover 3 meters. In another second the body covers may 5 meters. In the next second it may be only covers the 2 meters, like the 2, 5, 4, 7, 4, 3, sometimes 0. So that is what the difference between average and instantaneous velocity. Of course, in some of the cases, in every minute, in every second 2 meters only covered, then the average and instantaneous both are equal. Both are equal means in the uniform motion only this average and instantaneous values are same. Non-uniform motion, these two are different, is what my important point here. If in each over that team made 10 runs only, then this average run per hour and instantaneous runs per hour are same. That is what the difference between the average velocity and the instantaneous velocity. Understood, students? Right? So in the next video we will discuss about the acceleration, average acceleration and instantaneous acceleration. And to understand this d by dt of instantaneous, you need the fundamentals of differentiation and integration, that we will discuss in the further videos. This is what very important, so which is key for entire physics. Thank you, students. Thank you for watching. If you like my videos, do like, share, comment and subscribe our channel to get more videos.